Imagine pointing the most powerful space telescope ever built toward a planet just over 4 light-years away, and seeing something that shouldn't be there. That is the mystery surrounding Proxima Centauri b in this fictional scenario. Orbiting the red dwarf Proxima Centauri, this distant world has fascinated astronomers for years because of its relatively close location and its position within the star's potentially habitable zone. But now imagine that observations reveal faint patches of infrared emission appearing on the planet's dark hemisphere. At first, scientists would assume the glow was natural. Perhaps volcanic activity was producing heat. Maybe atmospheric circulation was moving energy from the illuminated side toward the darkness. It could even be a strange interaction between the planet's atmosphere and the intense radiation from its parent star. But then the pattern would repeat. Instead of appearing randomly, the emission would seem concentrated in particular regions. Some areas would become slightly brighter while others faded, creating a pattern that appeared strangely organized. That would immediately attract attention. The James Webb Space Telescope is designed to study the universe through infrared light, allowing astronomers to investigate the atmospheres and temperatures of distant worlds. But detecting something resembling artificial illumination from an exoplanet would be extraordinarily difficult. The signal would be incredibly faint. Proxima Centauri b is separated from Earth by more than 4 light-years. Any light reaching us today began its journey more than 4 years ago. And there is another problem. A telescope cannot simply look at Proxima b and resolve individual buildings or streets. The planet is far too small and distant. Scientists would instead have to examine its combined light and search for unusual spectral or thermal characteristics. Suppose those observations revealed an unexpected concentration of heat on the planet's night side. The discovery would raise a fascinating question. What could be generating it? Natural explanations would come first. A tidally influenced planet could have complicated atmospheric circulation. Geological activity could release enormous amounts of heat. Interactions with the magnetic field of its red dwarf star could also produce unusual emissions. But imagine that repeated observations continued to reveal the same localized structures. The hypothesis of technology would suddenly become impossible to ignore. Perhaps the hypothetical civilization uses enormous energy systems to move heat across the planet. Perhaps its settlements exist beneath the surface, protected from stellar radiation. Or perhaps what appears to be artificial light is something completely unknown to terrestrial science. Astronomers would then search the atmosphere for additional clues. They could investigate molecules such as methane, carbon dioxide, water vapor, and other compounds. The key would not necessarily be finding one particular gas. Instead, scientists would look for an atmospheric combination that is difficult to maintain naturally and might indicate biological or technological activity. They could also search for potential industrial signatures, chemical compounds that natural processes rarely produce in large quantities. At the same time, radio observatories could monitor the system for narrow band or repeating signals. If no radio transmission appeared, that would not necessarily eliminate the possibility of life. Humanity itself has existed for thousands of years, yet our detectable technological radio emissions have existed for only a relatively short period. An advanced civilization might communicate using methods completely unfamiliar to us. Or perhaps it does not communicate at all. This is where the mystery becomes even more fascinating. What if the lights were not signs of an active civilization? What if they were remnants? A distant world could have experienced its own rise and fall billions of years ago. Any structures left behind might continue producing detectable heat long after their creators disappeared. In that case, astronomers would not be looking at living beings. They would be observing the archaeological remains of another world. But before anyone could make such a claim, the evidence would have to survive intense scrutiny. Every natural explanation would need to be tested. Every measurement would need independent confirmation. And every apparent pattern would need to be shown as genuinely significant. Because a mysterious glow is not proof of alien cities. It is only a clue. And if that clue survived every investigation, humanity would face one of the greatest questions in history. Are we looking at nature behaving in an unfamiliar way, or at the first distant evidence of another technological civilization? The real significance of a discovery like this would not come from the brightness itself. It would come from the pattern. Natural objects can shine. Stars produce enormous amounts of energy. Volcanoes glow. Atmospheres scatter radiation. Magnetic fields can generate powerful emissions. But technology can create something different: organized energy use. On Earth, cities produce heat and light because billions of people continuously consume energy. If astronomers ever detected a distant planet displaying unmistakable signatures of large-scale artificial energy consumption, the discovery would fundamentally change our understanding of life in the universe. Imagine that observations of Proxima Centauri b continue for years. Each observation reveals the same unusual regions. The locations remain stable relative to the planet. Their intensity changes according to a predictable pattern. And the spectrum contains characteristics that natural processes struggle to explain. Scientists would begin constructing competing models. One model might suggest enormous geological activity. Another could involve unusual atmospheric chemistry. A third might propose electromagnetic interactions with the red dwarf star. And another could investigate technology. None of these explanations could simply be accepted because one sounded more exciting. The scientific process would require evidence. Independent telescopes would observe the system. Different instruments would examine different wavelengths. Researchers would compare observations across multiple years. The goal would be to determine whether the anomaly belongs to the planet itself or is caused by something between Proxima and Earth. Then comes one of the most important possibilities: atmospheric chemistry. If the planet contained a combination of gases that should rapidly react with one another but remained present in significant quantities, scientists would have a potential sign of continuous replenishment. That could come from biology. Or, theoretically, technology. Industrial civilization could leave chemical fingerprints in an atmosphere. Waste gases, manufactured compounds, and enormous amounts of excess heat could become detectable from across interstellar distances. The same principle applies to energy. Every civilization using technology generates waste heat. Humanity does it constantly. Our buildings, power plants, vehicles, factories, computers, and machines all transform energy and release some of it as heat. A sufficiently advanced civilization operating on a planetary scale could potentially leave an enormous thermal signature. That does not mean Proxima b actually has such a civilization. At present, there is no confirmed evidence that artificial city lights have been detected there. But as a scientific thought experiment, the possibility is fascinating. Future observatories could make increasingly sensitive measurements of nearby exoplanets. Large ground-based telescopes may provide additional information about their atmospheres and environments. Radio observatories could continue searching for structured signals. And space telescopes could examine how these worlds reflect, absorb, and emit radiation. Eventually, one observation might produce the decisive clue. Or the mystery might disappear completely. A supposed artificial glow could turn out to be volcanic activity. An unusual spectrum could come from an unexpected atmospheric process. A repeating pattern could be caused by the planet's rotation. Science advances not only through discoveries, but through eliminating incorrect explanations. And that is why the search for extraterrestrial intelligence is so compelling. Scientists are not simply looking for little green beings or dramatic messages. They are searching for evidence that another world has produced something that nature alone cannot easily explain. A signal. A chemical fingerprint. A strange thermal pattern. An unmistakable technological signature. If such evidence were ever confirmed around Proxima Centauri, the impact would extend far beyond astronomy. Humanity would suddenly have a new perspective on itself. Every border on Earth would remain exactly where it was. Our cities would remain where they are. Our problems would not instantly disappear. But our understanding of existence would change forever. For the first time, we would know that intelligence had emerged independently somewhere beyond Earth. And then another question would become unavoidable. Are they looking toward us? Perhaps they have never noticed Earth. Perhaps their civilization disappeared long ago. Perhaps they are still developing, just as humanity once did. Or perhaps they are listening to the same universe we are listening to. The most extraordinary possibility is also the simplest. That somewhere beneath another star, another civilization may have looked into its own night sky and wondered whether it was alone. And if one day humanity finally discovers unmistakable evidence of those distant lights, the story of civilization will be divided into two eras. The time when we wondered whether we were alone,